Dear students, very good afternoon. Today we are going to discuss about an important topic in engineering mathematics, and it is important for your entire life too because the topic itself is having so many applications in real life. The topic today we are going to discuss is ordinary differential equation. The topic today we are going to discuss is ordinary differential equations. Ordinary differential equations. Ordinary differential equations. In short form, it will be called as ODE. Okay, so this topic plays a very important role in daily life. If you want to calculate velocity is denoted by rate of change of displacement with respect to time, where x is the displacement, and t is time. In the same way, if you want to calculate the acceleration, then it is given by a. So a is nothing but dv by dt. So here v is velocity, t is time. So what is this equation called as? These equations are called as modeling. These equations are called as modeling. So modeling means, see, for a real life scenario, when you are having a replica, or when you are having a model, then it is very useful. It is a real home. Means for this real home you need a model. You need a model. So the model replicates the real life. The model should not be an example of the same real life. Sometimes it may be the plan. That is called blueprint. How to construct a home. So you will have blueprint. So according to the blueprint you will construct a home. Okay, so the miniature of a real life example is called modeling actually. But in differential equations we are not going to construct any physical models. We are going to construct the equation based models. Okay, suppose if you are taking a cup of coffee, okay, the coffee is now in the temperature 100 degrees Celsius, that is at its maximum temperature. After 10 minutes the temperature may reduce to 60 degrees Celsius, and after another 20 minutes the temperature reduces to 10 degrees Celsius and it comes to room temperature, and after that it comes to 0 also. Okay, so it becomes it comes to the room temperature. There will no heat at all. So here what can we say? The temperature of the coffee depends upon time. Temperature of coffee depends on time. So for the real life situation, drinking coffee is possible only if we cook the coffee, only if we heat the coffee. Okay, So here we are going to see an example. So Newton calling it as dq by dt. See, Newton calling it as dq. Q be the loss of temperature and T be the time. So Newton calling it as dq by dt. Here the temperature is getting decreased. So you can write minus k into T minus Ts. T minus Ts. Why? Because according to Newton, Q, the rate of loss in temperature of the body, that is coffee, will be equal to D, will be equal to, or will be proportional to, actually this is a proportional, dq by dt is proportional to the difference in temperature of surrounding of the object and the surrounding. You can write it as TO minus TS. Okay, TO and TS. So initially the temperature will be in 100, the surrounding temperature will be 30. If you are living in your house, the room temperature may be some 30 degrees Celsius to 50 degrees Celsius, whereas a coffee temperature will be 100 degrees Celsius. But you want to make the equation such that this equation should model the loss in temperature of the object, the loss in temperature of the coffee. So the object is coffee. This Q represents the loss in temperature of coffee. So this loss in temperature of coffee is directly proportional to difference between the difference, that is minus of difference between the surrounding temperature from the object temperature. So here a proportionality constant is K. Here a proportionality constant is K. So you can have this. Even though if you put plus here, you have to take the minus K as a proportionality constant. But this is okay. I think you can understand why we need the concept of ordinary differential equations. So the reason for this ordinary differential equation is first of all formation of equations. Formation of differential equations. In applied mathematics, we need three things. One is formation of differential equations, that is called modeling. Second one is solutions of differential equations. Third one is interpretation. Okay, interpretation of the solution. So these are the three important things that paved a way for the formation of differential equations. Okay, so here we want to know the definition of differential equations. In ordinary differential equation, the ordinary differential equation, that is ODE, consists of three things. One is variables, and second one is derivatives. Third one is constants, and these three are related by an operators. Okay, so the general form of linear differential equations of the nth order with with constant coefficients is given by d power ny divided by dx power n plus k1 of d power n minus 1 y divided by dx power n minus 1 plus k2 into d power n minus 2y divided by dx power n minus 2 plus etc. plus kn y equal to some function of x. Some function, this capital X gives us the function of x. Here you can see y and x are variables. Y is dependent variable, whereas x is independent variable. Okay, so you get this structure. Now this can be further written in the operator form. So we call capital D as the differential operator. So the above equation operator form, the above equation can be written as d power n plus k1 d power n minus 1 plus k2 d power n minus 2 plus etc. plus kn of y equal to capital X. Here that is where k1, k2 etc. kn are constants. So here you are not having any coefficients for the higher power. If you have any coefficients, that is not a constant coefficient. If you have any variable coefficients, that is any functions of x before, you will get Cauchy-Euler type of equations or the Legendre type of equations. Okay, so we will discuss them in future. Now you simply think the constant coefficients, that is not for the, that is for the terms other than the higher power of, that is other than the higher order derivative. Okay, see here, this is the derivative, d by dx means derivative. Okay, in a separate video I shall tell you what is actually derivative. Okay, how the concept of derivative was given by Newton. We shall discuss all those things. Okay, now we are getting into the syllabus. Here you have to know this d power ny means d power ny by dx power n. D power n minus 1 of y means you will get d power n minus 1 of y by dx power n minus 1. dy means you will get dy by dx. In the same way you get like this. Okay, so okay, now you may come across in your higher secondary during your, maybe in your plus 2 days, you may come across the general form of second order linear differential equation. Second order linear differential equations, that is d square y by dx square plus py plus, sorry, d square by dx square plus p into dy by dx plus q equal to r, plus q equal to r, where p and q are constants, where p comma q are constants. Capital R is a function of x, is a function of x, or sometimes it may be a constant, or sometimes it may be a constant. So how will you write this equation operator form? D square plus PD, okay, PD of y, here also you are having y now, so you will get here also you are having y, so you will get, you can write it as d square, you can write it as d square plus PD plus q of y equal to capital R. Okay, so this is the required equation. Here we are having some important ideas. Before going to the types of, or before going to classifications, you have to be aware of such things. So when you are having the symbol D, when you are having the symbol D, you have to see where this D comes, whether D comes in numerator, D in numerator, or D in denominator. Okay, you have to think about that, you have to very carefully check that. If you have D in numerator, D, you will have D, that is differentiation, Suppose if you are having 1 by t, D in denominator means that is 1 by t, it will represent integration. If you are having D square, you have to differentiate twice. You have to differentiate twice. If you are having 1 by d square, you have to integrate twice, and so on. Okay, so now suppose if we are having a second order equation, equation like d square y by dx square plus pdy plus q equal to r, then how will you write this in operator form? We have already discussed. You will write it as d square plus pd plus q of y equal to r. Okay, so this is a differential equation. Okay, so any differential equation will have the solution given by here the function is solvable for the dependent variable y, different variable y. So you will have a solution y equal to, always you will have complementary function, complementary function, and along with that you will have particular integral. Okay, so always you will have this will be your solution, when you are having such differential equations. when you are having such differential equations. I am for example giving this, okay, but you can have a cubic equation, or sometimes you can have a nth order equation also. Whatever you have, your solution will be y equal to complementary function and particular integral. Okay, you have to know one thing: the particular integral purely depends on right hand side, that is this r, okay, whereas the complementary function purely depends on the roots, the roots of this can be written as m square plus pm plus q equal to 0. All these would be replaced by m. Okay, so the complementary function depends on the above equation, d square plus pd plus q equal to 0. You can replace d by m, and the particular integral depends on right hand side. Okay, so depending on this idea, first of all we shall discuss about complementary function. Complementary function. So when you for example when you take a quadratic equation, that is d square plus pd plus q of y equal to r, means you have to first replace, you have to write the auxiliary equation. You have to write the auxiliary equation. The auxiliary equations au xi ll ary, okay, au xi li, okay, li ary. This is called auxiliary equation. Au xi li ey auxiliary equations, that is obtained by d replaced by m. So when you are having this equation and replace this d by m and put r equal to 0, okay, so you will have m square plus pm plus q equal to 0. And second thing is you have to factorize this. So factorize the m square plus pm plus q equal to 0 equation. You have to factorize this equation. Okay, on factorizing these equations, what are the chances of roots? You will have following cases. Roots of auxiliary equation and their complementary function. So I have already told you the complementary function purely depends on the auxiliary equation, that is m square plus pm plus q equal to 0. Okay, so the roots may be equal. You may have two roots, that is you may have m1 and also m2. This m1 equal to a value and this m2 may also equal to a value. This implies m1 equal to m2 equal to m. So the roots are equal. Therefore you can have ax plus b into e power mx, or you can also write it as a plus bx into e power mx. Suppose if you are considering a cubic equation, for example d cube y by dx cube plus p into d square y by d p1, you can take p1 dx square plus P2 into dy by dx plus P3 equal to R means P3y means you may have three roots also, and if all the three roots are equal, what will you get? M1 equal to M2 equal to M3. All these three roots are equal to a value M, means you can get three things, that is ax square plus bx plus c equal into e power mx, or a plus bx plus cx square of e power mx. Okay, this will be your complementary function. Suppose if your roots are different, what will be your complementary function? That is what we are going to see. So here m1 not equal to m2 means you will have a e power m1x plus b e power m2x. Okay, e power m1x plus b e power m2x. Suppose if you are considering this equation and the roots are not equal, means you will not get the equality between them. So you will get m1 not equal to m2 not equal to m3. So you will get a e power m1x plus b e power m2x plus c e power m3x. Okay, the third thing is the roots are complex roots. The third thing is complex roots are imaginary roots. Most probably it will be called as imaginary roots. The roots are imaginary. You can avoid this term. Okay, you can avoid this term. Most probably you will get imaginary roots, but if you are involving an imaginary term, it will become complex. Okay, so there are complex roots, that is alpha plus or minus I beta. Here you have to think very carefully. You can write alpha plus I beta or alpha minus I beta, whatever it may be. Your roots will be CF equal to e power alpha x into a cos beta x plus b sin beta x. A cos beta x plus b sin beta x. Okay, so this is the basic idea of complementary function. Okay, CF equal to I have written CF complementary function equal to. Okay, now we are going for particular integral. Okay, now we are going for particular in this the concept is over. Now we are going for particular integral. The particular integral will be given by is always depending on R, and it will be given by particular integral equal to 1 by f of d into capital X. Your capital X is nothing but your right hand side, f of d into right hand side. But we don't want to put this R, because this R is sharing two things. One is function of x and another one is 0. So in order to avoid that, we only take as 1 by f of d into capital X. If you are having 0, means your solution will be y equal to CF only. If you are having x, means your solution will be y equal to complementary function plus particular integral. Okay, if you are having 0, you will get only y equal to CF. Okay, what is this f of d? This f of d is nothing but d square plus pd plus q for second order linear differential equation. For nth order it will be d power n plus p into or k1 into d power n minus 1 plus etc plus kn okay, plus etc plus kn. This will be your f of d. Okay, so here depending upon the type of x you will have particular. So write the type of x and their pi here. Suppose if I am having capital X, that is your right hand side to be e power x, means your particular integral will be 1 by f of d into e power ax, that is equal to, that is you have to do some procedure. You have to replace d by a. You have to replace d by a. Okay, you have to replace d by a. If your denominator f of a becomes 0 means, if f of a becomes 0 means you have to differentiate the denominator. You have different denominator. That is, you have to do this. Then your pi will become x by f dash of d at a, d equal to a into e power x. If suppose this also becomes 0, means your pi will be x squared divided by f double dash of d, and you have to replace d by a, and you have to multiply by e power x. Okay, so this will be your particular integral. Okay, just to go through the type, but please don't strain much on this concept. Okay, the concept will be understood by default if you come across the problems. Okay, so please don't try to mug up the concept. Okay, just simply look into the concept, and after seeing some examples you can easily understand the concept. Okay, but it is necessary for a mathematician like me to explain the concept very briefly before starting a problem, because concept is everything in mathematics. Okay, the second type is x power n. If you are having x power n, your particular integral will be 1 by f of d of x power n. So here you have to make the denominator as f of d whole power minus 1 into x power n. This f of d should be 1 plus something, 1 plus right, for example 1 plus you can take 1 plus powers of d, 1 plus powers of d, or 1 plus some more functions of d. Okay, 1 plus g of d. You have to take the least power outside. And you have to make this. So because from this you can get a binomial expansion 1 plus ax whole power minus 1. Suppose if you are having minus here, you can take 1 minus x whole power minus 1 and 1 plus x whole power minus 2 and 1 minus x whole power minus 2. Here you will have the functions of d. Yes. So okay. So in this method also, when the denominator f of d becomes 0, you have to take pi as, multiplying by x. In numerator you have to differentiate denominator f dash of d into at d equal to a, and you have to multiply it by x power n, and you have to multiply it by x power n. Okay, so you have to be very conscious in that. Whenever denominator is becoming 0, you have to multiply the denominator, you have to multiply the numerator by x, and you have to differentiate the denominator. Always keep that in mind. Okay. Okay. Now the third type is sin ax or cos ax. Okay, cos ax. So if you are having this, you can find a particular integral in following ways. That is pi equal to 1 by f of d into cos ax or sin ax. Here you have to replace the d square by minus a square, minus of a square. Okay, it is not minus a the whole square. Okay, it is wrong. Okay, it is, you should have them first you have to make a square and you have to multiply it by minus. That is very important. This is one method. Okay, so here you will get some expression, and after that if you have any other functions of d, that is g of d, in denominator means you have to take the conjugate. You have to take the conjugate of denominator. Okay, denominator. The fourth type is the e power ax combining with other terms. E power x combining with other terms. So for that you have to do pi equal to 1 by f of d into e power ax into phi of x into phi of x. Here you will have e power of, here you will have e power of ax, here you will have e power of ax into 1 by f of d plus a, into phi of x. If you are having e power of minus ax into phi of x, then you will have see, for example, if you are having e power of minus ax into phi of x, you will have pi equal to e power minus ax 1 by f of d minus a into phi of x. Okay, so this is the basic fundamental things in the introduction of ordinary differential equations. You may aware of this binomial expansion. So during problem I shall explain all the binomial expansions. So kindly take down this introduction in your notebook. We shall go to the problems in our upcoming videos. Thank you all for watching this video. Thank you all once again.